In this lesson, our goal is to apply the sine and cosine laws to situations that involve obtuse triangles. If we recall from our previous investigation, for any angle theta, sine theta is equal to the sine of 180 degrees minus theta. Cos theta is equal to the negative cos of 180 minus theta, and tan theta is equal to the negative tan of 180 minus theta. This is going to be very important when we're solving problems using the sine law. We want to determine the measure of angle A to the nearest tenth of a degree. So what we have to do is we have to determine whether we are going to use the law of sines or the law of cosines. In this case, we are given two sides and an angle, but the angle is not included between the two sides. Therefore, we are going to be using the sine law. What we want to find is we want to find angle A. So that's what we're looking for. We do know its opposite side measure, and we do have another set of opposite measurements. So we can use 65 divided by sine theta is equal to 40 divided by sine 23. So we have 65 divided by sine theta and 40 divided by 0.3907. Multiply 65 times 0.3907, 25.3955 equals 40 times sine theta. We want to solve for sine theta, so we're going to divide both sides by 40. We get 0.63489 equals sine theta. And now because we are looking for the angle measure, remember we have to use our second function or our shift button so that we're using the inverse operation. And we end up with 39.4 equals theta. Now what you have to ask yourself is that a reasonable answer if you look at your diagram? What kind of an angle was angle A in the diagram? Hopefully you've recognized that it was an obtuse angle. Now this goes back to the rule we learned in the investigation. The value for sine theta is exactly the same as its supplement angle, the sine of its supplement angle. So in this case, what you need to now recognize is that you have to determine, do we use the acute angle measure or should we be using the obtuse angle measure? And in this case, we should be using the obtuse angle measurement. So we need to go 180, subtract 39.4, and we get 140.6 degrees. And that is the correct measurement for angle A, which is in this case, we let it represent by theta. So when you are using the law of sines, you have to, once you've got your final answer, you need to determine, is that correct or do you need to find the obtuse information? In this next example, we have the roof of a house consists of two slanted sections as shown. A roofing cap is being made to fit the crown of the roof where the two slanted sections meet. Determine the measure of the angle needed for the roofing cap to the nearest tenth of a degree. In this diagram, we are given all three sides. And when we are given all three sides, we are going to use the law of cosines. Now we can let this one be whatever we want. If we want it to be A, B, or C, it does not matter. But if we are looking for angle A, then we are using the version of the cosine law. A squared equals B squared plus C squared minus 2BC cos A. A squared is the side opposite the angle we are looking for. B and C are the two other sides. And we are looking for angle A. So now we go through and we find these measurements. And here we just make sure we do 2 times 17 times 20.3. So we have 690.2 cos A. We can add up our 289 and our 412. And we're trying to solve for cos A, so we're going to start by subtracting our 701 from both sides. So we have 421 equals negative 690.2 cos A. We are going to divide by negative 690.2. And again, when we are looking for an angle measure, you are going to use your second function or your shift button to find the inverse of cos. And we end up with 127.6 degrees equals A. Now we have to determine if that is reasonable, 127.6 degrees. That is reasonable. It looks like it is an obtuse angle. And so therefore, that is our answer. So the key ideas: the sine law and cosine law can be used to determine unknown sine lengths and angle measures in obtuse triangles. The sine law and cosine law are used with obtuse triangles in the same way they are used with acute triangles. So just as before, use the sine law if you know two sides and a non-included angle, or if you know two angles and the length of any side. You use the cosine law when you know two sides and the included angle, or when you know the lengths of all three sides. There are some differences though when you are using obtuse triangles. You must be careful when using the sine law to determine the measure of an angle. The inverse sine of a ratio always gives you an acute angle, but the supplementary angle has the same ratio. You must decide whether the acute angle or the obtuse angle is the correct angle for your triangle. So if you think back to the first example, that's what we had to do. We came up with the acute angle, but the triangle definitely had an obtuse angle in it, so we had to find the supplement. Because the cosine ratios for an angle and its supplement are not equal, they are in fact opposites, the measures of the angles determined using the cosine law are always correct. So when you're using the law of cosines, you don't have to worry about finding the supplement angle. That's only when you are using the sine law.